Hi, I'm going to go through the steps to set up a reverse proxy server so that you can self-host a backend for a web app behind a router. Now let's start with the bare bones basic web server that hosts Hello World. Now obviously this can't be accessed from the wider internet. Now if you have a static IP address or are able to use a dynamic DNS, then you can configure your router to be able to access this web server. But in that instance you will need an SSL certificate. You can use Certbot to quite painlessly get a free SSL certificate for your site. The reason you need an SSL certificate, even though the security has arguably been broken due to content delivery networks, is that browsers and search engines have come to expect it under the guise of enforcing security. If, however, your backend is behind a router using NAT, e.g. you are using a mobile network, you will need to use a reverse proxy server. In this network diagram, this here is the reverse proxy server, and here we have backend servers. So the backend server will establish a connection with the reverse proxy server, and then internet traffic will then talk to the reverse proxy server, and the reverse proxy server will act as a go-between with the backend server. Now the reverse proxy server will have a SSL certificate, so your front end, which will have a SSL certificate, will happily be able to communicate with the reverse proxy server. However, there's no proof of authorship between the reverse proxy server and the backend servers. So what I'm going to do is I'm going to send a signature along with my content response. I'm going to send a signature in the form of a JSON Web Signature, JWS. And the JWS JSON Web Signature will provide proof of authorship so that the front end knows that it was my back end via the reverse proxy server that sent the response. So I'm going to modify this simple web server so that the response includes a JSON web signature of the requested content. So briefly, what is a JSON web signature? It is a standard way of serializing signature data. So if we look at the spec, we have a header, we have the payload, and we have a signature, all of which is base64 encoded. If we bring up a base64 decoder, we will see here we've got the header defining the characteristics of the signature. We have the payload, my content, hello world, and an expiration date, and then we have the signature. So using this standard, we can then simply rely on libraries to sign, check signatures, encrypt, and decrypt as required. Now I'm going to put everything together. I'm going to make a production version of the web server using Apache. Now, every time the Python server has started, we've seen this message: do not use in production, use a production WSG server instead. Now, there is a mod available for Apache, and here is the documentation on Flask's website, which walks you through setting up a Flask application to work with Apache. I'm going to need to write some front-end code so that the client can validate the JSON web signature against a distributed public key. Now here's a really interesting project. Localtunnel is a reverse proxy server which also translates HTTP to HTTPS. So Localtunnel allows you to easily share a web service on your local development machine without messing with DNS and firewall settings. Localtunnel will assign you a unique publicly accessible URL that will proxy all requests to your local running machine. So here's the GitHub repository. You can actually run your own server. I'm going to install this globally. Now I have an Apache server 7070/API will return my JSON Web Signature. So if I do LT port 7070, I get back this URL. Now if I do a curl request to this URL /API, I get my JSON Web Signature. This is a great service. Now, incorporating this into a website, you could use Web3 technology such as the interplanetary file system or maybe NoString in order to broadcast this URL endpoint just in case it changes. Here's a simple script which fetches from this URL and then verifies the JSON Web Signature response. And I've also got the Apache log here as well. So let me just run this. So here we have the response of the JSON Web Signature, and here we have the output of the verification, so it has verified. So moving on, this process here will stop whenever there's a network interruption and the URL will be regenerated, which means that any code in the front end will break because the URL will change. So we're going to need some sort of method to keep track of the URLs. Now we can use Web3 technologies like interplanetary file system or maybe a news feed like NoString. I'm going to try and use a gist from GitHub. So now I'm going to put together a wrapper which pulls out this URL and posts it to an endpoint that the front end website can retrieve. And the wrapper will also need to restart this process if it fails. Here I've got a bash script which starts the Localtunnel program and pulls out the URL. You could then set up a service that runs this bash script and restarts upon failure, which as a result could then continuously update the gist or data repository of the current relevant URL. So here we have my GitHub Gist, and if I stop this script and then run the script again, so there we go. So this script is starting the Localtunnel program, which is making a link with the reverse proxy server, and it is updating this gist. So then in the front end you can obtain this URL, which will then update whenever the link with the reverse proxy server is broken and the URL is updated. So in conclusion, using a reverse proxy server is a viable method to allow you to self-host your own back end behind a router. One limitation is the response data is not encrypted, but I can't see a way to achieve that without people being more accustomed to public-private key cryptography. Now, moving forward, I'm going to try and utilize this method in one of my own projects to see how practical it is in production.